Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin.
In the endless silence of space, black holes have long captured our imagination, swallowing light, time, and even the stories of stars that dared to come too close. But somewhere within the mathematics of Einstein's equations, another possibility whispers. A mirror twin and opposite, not a mouth that devours, but a fountain that releases. These are the white holes, the silent gateways of the cosmos, imagined but never seen, thought of as the theoretical twins of black holes. To dream of a white hole is to dream of a place where nothing can enter, only escape. Picture a door forever locked from the outside, yet from within comes a stream of light, dust, and time itself. Scientists describe black holes as regions from which nothing can return. White holes, on the other hand, would be regions where nothing could remain. They would push everything outward endlessly, as if the universe itself were exhaling. It begins with the equations. When Einstein wrote his general theory of relativity, he gave the world a set of rules that described how mass bends space and time. These equations birthed the concept of the black hole, first as a mathematical curiosity and later as an astrophysical certainty. But the very same equations, when stretched to their full solutions, opened up the door to another possibility. Where a black hole takes in, a white hole expels. Together, they form a symmetry that seems to balance the scales of cosmic order. Imagine falling toward a black hole. Your vision stretches, your time slows, and from the outside your descent appears eternal. Yet if there exists a white hole, the story reverses. Instead of endless falling inward, matter and light would be cast outward, never permitted to cross the horizon from the other side. It would be as if the universe itself was replaying the collapse of a star in reverse, like watching ash leap from fire to reform a tree, impossible yet hauntingly beautiful. But why has no one ever seen a white hole? The answer lies in the fragility of the concept. In our universe, entropy grows, disorder increases. Black holes fit this picture perfectly. They are the ultimate consumers, gathering chaos and never letting it go. White holes, by contrast, appear unstable. To exist, they would have to decrease entropy, reversing the arrow of time. The very laws that govern our universe seem to reject them, as if nature herself gently closes the door on such an idea. Still, scientists do not abandon the dream so easily. Some wonder if the birth of our universe itself was a kind of white hole. The Big Bang, that great moment of sudden expansion, carries the flavor of a white hole, matter and light rushing outward, unstoppable with no way to look back inside. Could our cosmos have sprung from such an event, a one-time outpouring that still echoes in the faint microwave glow we call the afterlight of creation? Others imagine that black holes and white holes may be connected. In this vision, the death of a star collapses into a black hole, but deep inside, beyond the singularity, lies a bridge. On the other side of that bridge is not nothing, but another universe, another region of space and time, birthed by a white hole's explosion. This idea, tied to the dream of wormholes, paints the universe as a network of tunnels, some swallowing, some exhaling, all weaving together a grand tapestry we can only barely imagine. The mathematics that support white holes are delicate, precise, and unyielding in their elegance. They suggest that time and space can be extended beyond what we see. Just as the black hole's event horizon marks a boundary beyond which no return is possible, the white hole's horizon marks a boundary where no entry can occur. These are the gates of the universe, one a mouth that swallows, the other a mouth that breathes out. When thinking about white holes, one cannot help but drift into metaphors of life itself. Inhaling and exhaling, birth and death, black holes as the ultimate consumers, endings with no return, white holes as beginnings, fountains that can only give. Together they resemble the cycles of nature, the falling of leaves and the blossoming of spring, the setting of the sun and the rising of dawn. Perhaps in the mathematics of relativity, the universe has mirrored this eternal rhythm. Even if white holes never exist in reality, they serve as a kind of cosmic poetry. They remind us that the universe is not always simple, not always bound to our expectations. They invite us to dream of impossible symmetries, of hidden worlds where light runs backward, where time is released instead of consumed. They whisper to us in the quiet of thought that nature may hold more secrets than we can ever touch. And so, as we drift deeper into the silent gateways of the cosmos, the white hole remains an idea suspended between science and dream. It is a question that humbles us, a vision that stirs the imagination, a possibility that teaches us that even absence, even impossibility, has its own kind of beauty. Like the faintest star seen at the edge of vision, it flickers there, unseen, unproven, but not forgotten. When we imagine white holes more deeply, we find ourselves standing at the edge of a paradox. Our universe, as we know it, seems to favor the path of least resistance. It loves collapse, decay, and the quiet slide toward disorder. But white holes, if they were real, would push against this current. They would be the great undoers, fountains of order pouring into the sea of chaos. The very thought of them feels like a dream told backwards, like a film rewinding, where shattered glass leaps from the floor and reforms whole in the palm of your hand. The mind resists it, yet the mathematics does not let the idea disappear. It lingers like a soft echo. Scientists often turn to thought experiments to explore what they cannot touch. Imagine, for a moment, watching a galaxy form in reverse. Instead of stars burning their fuel and collapsing inward, they would seem to uncollapse, releasing their energy into newborn gas and dust, scattering into a radiant cloud. A white hole could be seen in much the same way, the final breath of a system, reimagined as its first. In the equations of relativity, it is not forbidden. It simply sits there, a hidden possibility, waiting for meaning. The most famous black hole solution in Einstein's mathematics is called the Schwarzschild solution. It describes a perfect, non-rotating, uncharged black hole, born from symmetry and simplicity. But embedded within that same solution lies the idea of a white hole. Mathematically, they are like two sides of the same coin. Where the black hole represents the future boundary of space-time, the white hole represents the past. One is a trap into which all paths fall. The other is a fountain from which all paths emerge. Together, they complete the picture. And yet this completion feels uneasy. For in the real world, we do not see fountains. We see collapse. Stars do not unburn their fuel. Planets do not rise again once consumed. If white holes exist, they must be fleeting, fragile, gone before they can be born. Some physicists suggest that they may appear as quantum echoes, small bursts of energy and light escaping the deep belly of black holes. In this way, the white hole is not a twin that stands alone, but a reflection, a shimmer, born from the death throes of its sibling. The connection between black holes and white holes becomes even more haunting when we consider wormholes. A wormhole is the theoretical tunnel that links two regions of space-time. On one side may be a black hole swallowing everything. On the other, a white hole spitting it back out. Like two mouths connected by a throat, they could allow matter and information to pass through, not vanish. In the soft light of imagination, such a structure would make the universe feel like a woven fabric, its threads knotted and looped in unseen ways, where falling into darkness might mean emerging into light elsewhere. But physics resists too much poetry. Wormholes, like white holes, are unstable in the cold mathematics of reality. They collapse before they can stabilize. They require exotic matter that bends the rules of energy itself to hold them open. Without it, they pinch shut faster than a blink, locking away their secrets forever. And so the dream of traveling through one, of entering the mouth of a black hole and stepping out into the breath of a white hole remains just that, a dream. Still, the question presses on. If white holes are unstable, if they cannot last, what role do they play in our understanding of the cosmos? One answer may lie in quantum gravity, the mysterious theory that physicists have sought for decades, where the laws of the very small, quantum mechanics, blend with the laws of the very large, relativity. Some suggest that black holes may not remain eternal prisons. Perhaps over unimaginable spans of time, they transform, releasing their contents not as hawking radiation alone, but in a sudden burst. This burst, some whisper, would look exactly like a white hole, a quiet, patient collapse reborn as an outpouring. Imagine that every black hole in the universe, silent now, waiting. Millions, perhaps billions of collapsed stars hiding their contents beyond the veil of their horizons. And then after ages longer than the age of galaxies, they awaken, not to devour but to release, an unspooling of light, matter, and memory into the vastness. In such a vision, the universe is not a graveyard of collapse but a cycle. Black holes and white holes would no longer be opposites, but stages, inhaling and exhaling across eternity. There is also the haunting idea that the Big Bang itself was nothing more than a white hole. In this picture, the singularity from which our universe expanded was not a beginning, but an ending elsewhere, the collapse of matter into a black hole in Anat. Her universe may have given birth to our cosmos through a white hole's explosion. Our sky, our stars, our very breath could be the echo of something falling inward, beyond our reach in another realm. It is a vision that folds science and wonder into one, the sense that every death is not an end, but a door. And as we trace these possibilities, the metaphors bloom like constellations. White holes become more than curiosities. They become symbols of reversal, of release, of renewal. They remind us that the universe is full of balance we cannot yet see. For every night a dawn, for every fall a rise, for every silence a voice waiting to return. Whether or not they exist, white holes give us the language to imagine such symmetry. They remind us that even in science, mystery is not a failure, but a gift. So let us drift further into this quiet vision. Picture yourself standing at the edge of a cosmic horizon where gravity's grip is infinite. Behind you lies collapse, the pull of darkness that admits no return. Ahead of you lies its reflection, the unseen, the untested, the bright release. Between them you float in wonder, listening to the silence of space, feeling the rhythm of inhale and exhale, black and white, devour and release. The cosmos hums with these possibilities, and we, fragile listeners, can only dream of what lies beyond. The idea of white holes often feels like a whisper that comes from the edge of imagination, a quiet voice reminding us that the universe may not always run in the direction we expect. As we reach the closing part of this story, let us slow down and allow ourselves to drift into the softer, more reflective side of what these mysterious twins could mean. For even if no telescope has ever found one, the thought of them brings with it a sense of balance, of poetry hidden inside physics, of doors that open only one way, outward. A black hole is finality. It is the last breath of a star, the swallowing of matter, the irreversible pull of gravity that leaves nothing behind but silence. A white hole, if it exists, is its reply. It would not trap but release, not hide but reveal. Imagine a fountain in the desert where nothing enters but everything flows out. Imagine a star that has no collapse, only a bloom. Such visions, though fragile, allow us to hold in our hearts the idea that the universe, too, can breathe both ways. One of the quiet truths of science is that even failed ideas can guide us toward deeper understanding. White holes may never be observed, yet they force us to ask questions about time, about entropy, about beginnings and endings. They ask us to wonder if the universe is more cyclical than we imagine, if creation and collapse are not opposites but companions. In the same way a river both gathers and gives, perhaps the cosmos also holds within it a rhythm of gathering and giving, of devouring and exhaling, of black holes and white holes. There is beauty in the way physicists speak of symmetry. Nature often balances its scales, pairing forces and particles, light and shadow, matter and antimatter. To dream of white holes is to extend that same longing for balance into the very fabric of space-time. Where there is a sink, perhaps there is a spring. Where there is a grave, perhaps there is a seed. Where there is an ending, perhaps somewhere there is a beginning. And though we cannot touch it, this symmetry calms us like a lullaby sung by the stars. Imagine for a moment that the matter consumed by black holes does not vanish forever. Imagine that, at some unreachable horizon, it reappears, scattered into a new universe, drifting like stardust across a new sky. We may never know if this is true, yet the thought is enough to remind us of something soft and human, that nothing is ever truly lost, only transformed. The white hole becomes not a physical object, but a metaphor for renewal, a cosmic promise that endings may carry seeds of beginnings. As we drift deeper, let us remember that the universe is not built only of equations and evidence. It is also built of wonder, of the ability to dream what has not yet been seen. White holes live in that territory, the thin space where science touches poetry. They are like the idea of dawn before the first light appears, or the hush of spring before the first green bud pushes through the soil. They are the possibility that something beyond our reach still breathes, waiting to surprise us. There are scientists who argue that white holes could never survive, that the moment they were born they would collapse, unstable, fleeting as a spark in wind. And yet even that fleeting spark is a gift. It shows us that the universe is not as rigid as we believe, that the same equations that explain collapse also allow for release. If nothing else, white holes are the universe's reminder that imagination is as much a tool as any telescope, and that questions are as important as answers. Think of the night sky now as its Stretch. He's over you, black holes lie hidden there, cloaked in darkness, their presence felt only by the dance of stars around them, the silence they carve in the fabric of space. Somewhere, perhaps only in thought, their twins exist too, unseen, unmeasured, but not entirely unreal. For every mouth that devours, a mouth that breathes out. For every silence, an echo. For every fall, a rise. This is the poetry that white holes give us. And so we end this story where we began, in wonder. White holes may never be found, yet they live on in our imaginations, teaching us to see beyond the obvious, to dream in reverse, to hold the possibility of balance even when all we see is collapse. They remind us that science is not only about what is, but about what could be, what might have been, what still waits in the quiet corners of the cosmos. In their absence, they still give. In their silence, they still whisper. And in their impossibility, they still shine. Rest now in that thought, that soft vision of the cosmos as a place not of endless devouring, but of endless giving. Rest in the rhythm of inhale and exhale, of black holes and white holes, of silence and song. The universe is vast, mysterious, and still unfolding, and though we may never touch its deepest gates, we are allowed to dream of them. That, in the end, may be the greatest gift of all. Light is the most loyal traveler of the cosmos. It streams across the emptiness, carrying the memory of stars, painting the universe with color, weaving the story of time. And yet there are places where even light is denied entry, places where its endless journey is stopped at the boundary of silence. Black holes are famous for this refusal, for their ability to trap light forever. But what of the spaces where the refusal takes another shape, where light is not trapped but never allowed in at all? This is the haunting thought of white holes, regions not of swallowing but of rejection, where light approaches but cannot cross, where the very act of entering is forbidden. To imagine such a thing is to imagine a gate that opens only one way. The black hole is a door that allows you to enter but never leave. The white hole, its twin, is a door that never lets you step through at all. From a distance, they are mirrors. Where the event horizon of a black hole swallows, the horizon of a white hole pushes away. Light itself, the most obedient of travelers, finds no path across. It must turn back, as though the universe itself is saying no. This refusal is strange, unsettling even, for light has always been the messenger of truth. It tells us where stars are born, how galaxies grow, how the universe expands. To think of a place where light cannot enter is to think of a silence deeper than we have ever known. A black hole keeps its secrets by locking them inside. A white hole keeps its secrets by never letting them in. Both are silent, but in different ways, one through possession, the other through denial. When Einstein's equations first revealed the possibility of black holes, they were seen as strange mathematical curiosities, unlikely to exist in nature. It took decades before astronomers began to believe they might truly be out there. White holes, however, have never made that leap. They remain largely on paper, in the clean ink of mathematics, like dreams that cannot quite survive in the daylight. And yet they fascinate us because they remind us of how much the universe resists simplicity, how even its equations seem to prefer balance. In physics, balance is not just a poetic idea but a structural one. Symmetries are everywhere. Every particle has an antiparticle. Every force has a counterweight. Time moves forward, but in the equations it can also move back. And so if a black hole exists, swallowing everything that dares approach, the mathematics insists there must also be its twin, the white hole, spitting everything out, refusing all attempts to enter. It is as if the universe, in its deep geometry, prefers to write in pairs. Let us pause and feel what this refusal means. Picture yourself as a beam of light flying across the cosmos, ancient and free. You cross starfields, nebulae, clouds of gas, the cold edges of galaxies. You have never been denied. And then before you a horizon rises, a pale, shimmering boundary where your path should continue but does not. You rush toward it, but at the very edge you find resistance, a push that sends you back. No matter how hard you try, no matter how straight your path, the horizon rejects you. You are light, the most untouchable thing in the universe, and even you cannot pass. What kind of silence lies beyond such a refusal? Some physicists wonder if this is the true nature of beginnings. The Big Bang, the great unfolding of our universe, has the flavor of a white hole. It was not a swallowing, but a release, matter and energy rushing outward from a point that could not be entered. Perhaps our entire cosmos began as such a refusal, a place where light and matter were not permitted to go inward, but only outward, outward forever. In that vision, the whole universe is born of a white hole's breath, and every galaxy, every star, every living being is part of that refusal to collapse. Still, the vision is fragile. The mathematics allows it, but the universe resists. White holes seem to defy the arrow of time, to move against entropy, to violate the great laws that shape everything we see. Where black holes fit neatly into the story of collapse, white holes seem to unravel it. And yet sometimes it is in the unraveling that we glimpse new threads. They remind us that science is not only about what we know, but about what we might one day dare to ask. The refusal of light to enter a white hole is more than physics. It is also metaphor. There are places in our own lives where entry is denied, where the path we long for remains closed. White holes become symbols for such mysteries, for the boundaries we cannot cross, for the silences that remain. And yet, even in refusal, there is beauty. For in being denied, light still travels, still shines, still carries its story onward. What cannot be entered still teaches us, quietly, about the limits of the universe and the humility of our place within it. And so the white hole remains, not seen, not proven, but not forgotten. A place where even light, the most tireless traveler, is gently turned away. A silence not of swallowing, but of refusal. A reminder that the cosmos holds not only doors that lock, but doors that never open. And in that thought, the universe becomes deeper, stranger, and somehow softer, a place where light itself must bow to mystery. The refusal of light to enter a white hole invites us to think more deeply about the laws that guide our universe. Light, after all, has always been the most faithful narrator of cosmic history. It tells us how far galaxies drift, how stars age, how atoms burn, how space itself expands. But when we imagine a white hole, we imagine a horizon that silences this narrator before the story even begins. It is as though the universe has drawn a boundary and whispered, "Here, even light shall not pass." What kind of truths are kept behind such a veil? What does it mean when the messenger is turned away? In the black hole, light enters but cannot escape. Its story continues, but only inward toward a singularity we cannot see. In the white hole, light cannot even begin the journey inward. Its very first step is refused. One kind of silence hides secrets, the other prevents secrets from ever forming. And so we find ourselves standing before two kinds of mystery, both born from the same mathematics, both telling us something different about the nature of existence. One says there are places you cannot reach. The other says there are places you cannot even enter. When physicists explore this idea, they speak of event horizons, those invisible borders where the rules of spacetime shift. For black holes, the horizon is a one-way surface. For white holes, it would be the same, but in reverse. Nothing comes in, everything goes out. If such a surface were real, it would be unlike anything else in the universe. Even neutron stars, dense as they are, allow light to pass across their surfaces. Only these theoretical horizons deny it. A white hole would be the pure embodiment of rejection, the geometry of no. This leads us to time itself. Because white holes suggest a reversal of entropy, they carry with them the flavor of backward time. Black holes grow as they consume, they follow the arrow of disorder. White holes would do the opposite, decreasing disorder, pushing matter outward, rebuilding structure. To exist, they would need to move against the flow of everything we know, against the current of time itself. It is no wonder, then, that scientists doubt their survival. They would be too fragile, too unstable, too contradictory to endure. And yet, their very impossibility makes them valuable. They force us to confront the edges of our understanding. Imagine for a moment that you are standing at the edge of a cosmic horizon where a white hole shines. Around you, light scatters, but none enters. Streams of radiation pour outward like a fountain that never runs dry. To an observer, it would look like a sudden explosion, a burst of matter and energy flung into the void with no apparent cause. It would be a spectacle of creation, yet without a seed, without a spark of ignition. It would look like magic, but it would simply be the mathematics of relativity taking form. Some theorists wonder if what we call gamma ray bursts, those sudden flashes of high-energy light that blaze across the universe, could be linked to phenomena like white holes. These bursts appear without warning, lasting only moments, yet brighter than whole galaxies. Most are explained by the collapse of massive stars or the collision of neutron stars, but some minds wise. What if a few are something stranger? What if a white hole flickered into existence for a brief moment, releasing what it held and then vanished? We may never know, but the thought lingers, quiet as starlight. Even Hawking's famous radiation, the gentle leakage of energy from black holes, carries a trace of this idea. Black holes are not entirely silent. Over unimaginable spans of time, they lose energy, evaporating slowly until nothing remains. Some scientists suggest that when this final moment comes, when the black hole has dwindled to almost nothing, it could release all that it once consumed in a single burst. That final burst would not be unlike a white hole, a sudden refusal to hold in, an outpouring of everything once trapped. In this way, black holes and white holes might not be separate beings, but two stages of the same life. The refusal of light to enter a white hole can also be seen as a symbol of protection. Imagine a chamber that no darkness can touch, a realm where no story of collapse is ever allowed to begin. White holes would be cosmic guardians of order, expelling chaos before it takes root. They may not exist in our skies, but in our thoughts they serve as reminders that not all doors open to consumption. Some remain outward, always giving, always releasing, never swallowing what approaches. As we drift deeper into this reflection, it becomes clear that the real power of white holes lies not in their presence, but in their absence. They live in the equations, in the imagination, in the delicate balance of possibility. They may never decorate our sky with their refusal, yet they decorate our thoughts with questions. Why does the universe allow one twin to exist and not the other? What does it mean that the mathematics offers both, but nature seems to choose only one? Perhaps the refusal is not just of light, but of reality itself, the cosmos declining to build what it can still imagine. And yet there is gentleness in this, for even if they never shine, white holes give us something to hold, the reminder that every path has its mirror, every silence its opposite, every boundary its reflection. They remind us that even light, which seems unstoppable, has its limits, and in learning those limits, we glimpse more of the universe's character. We learn that mystery is not a flaw but a feature, that refusal is not emptiness but meaning, that the cosmos speaks to us not only in answers but in pauses, in the quiet moments where even light cannot enter. The vision of a white hole remains suspended between science and dream, like a lantern floating above water, its glow reflected but never grasped. To think of a place where light is turned away is to think of the purest form of mystery, a silence not born from swallowing but from denial. As we close this story, let us move more slowly, as though each thought is a ripple on a still pond. What does it mean truly that even light, the most faithful traveler of the cosmos, might face a horizon where it is not welcome? In the black hole we find tragedy. Stars collapse, worlds fall, and even light is imprisoned, bound forever by gravity's pull. But in the white hole we find a kind of refusal that feels less tragic and more serene. It does not trap, it does not consume, it simply declines. It is a cosmic gesture of turning away, as if saying, "This is not your path." In that refusal lies a different kind of silence, not heavy with grief but quiet with distance, like the stillness of a mountain that cannot be climbed. Perhaps that is why white holes resonate so deeply with metaphor. They remind us that there are places in life where entry is impossible, where even our brightest efforts are turned aside. And yet, this does not mean failure. It means mystery. It means that not all doors open, that not all horizons are meant to be crossed. Just as light itself must retreat from the surface of a white hole, so too must we sometimes accept the boundaries placed before us and find beauty in the journey rather than the destination. The physics of such horizons continues to puzzle scientists, but it also inspires them. They ask, could a black hole's final death flare be a white hole's brief life? Could every collapse be balanced by a hidden release? Could the beginning of our universe, the Big Bang itself, have been a single, immense white hole? None of these questions are answered, and perhaps they never will be. Yet the asking itself is a kind of light, moving outward across the darkness of ignorance, carrying hope where certainty cannot. For light has always been our teacher. It shows us stars born billions of years ago. It shows us galaxies colliding in slow motion. It shows us the echo of creation itself, the faint microwave glow that still fills the sky. But in the dream of the white hole, light is not the storyteller but the student. For once it is refused, it is turned back, it is humbled. And in that humility we glimpse a deep truth that even the most powerful messengers are not infinite, that even light itself bows to mystery. Imagine again that you are a photon, a single particle of light, ancient and restless. You have crossed half a universe, carrying the story of your star across gulfs of silence. You have brushed past planets, danced around nebulae, glided through the arms of galaxies. You have never been denied, but now before you a white horizon gleams. You feel the pull of curiosity, the longing to cross. And yet, as you touch the edge, you are turned away, cast back into space. You carry nothing of what lies beyond, only the memory of being refused. That refusal becomes your story. That silence becomes your gift. In this way, white holes become not just cosmic curiosities, but mirrors of our own journeys. They teach us that mystery does not always lie within, waiting to be uncovered. Sometimes mystery lies beyond, forever closed, forever silent. And that too is part of existence. We cannot demand that every question be answered, every horizon be crossed, every silence be broken. Sometimes the refusal is itself the answer. Sometimes the pause is itself the song. And so we end with a kind of acceptance. White holes may never shine in our telescopes, may never be proven by experiment, may never exist outside the clean lines of mathematics. But they exist in thought, in poetry, in the delicate balance of what might be. They are the other half of a story we cannot yet tell, the silence that balances the voice, the horizon that balances the fall. In their imagined refusal, they still give us something precious, the chance to wonder, to dream, to pause before the unknown and feel at peace. The cosmos is vast and we are small, yet in our smallness we carry questions as large as stars. White holes remind us that not every question has an answer, not every path has a crossing, not every light has a way forward. They remind us that sometimes the most powerful truth is not in what is revealed, but in what is withheld. And in that gentle withholding we find not despair but calm. We find the grace of mystery. We find the beauty of silence. So let the story of white holes rest here at the edge of imagination. Let it be a reminder that the universe is not only made of what we see, but of what we cannot enter. That even light, swift and eternal, finds boundaries it cannot cross, and that in those boundaries we too can find stillness, acceptance, and wonder. For what is science if not the art of standing before mystery and listening, even when the answer is silence? Time is the quiet river that carries everything forward. It moves through galaxies and lives alike, steady and unbroken, whispering change into every corner of the cosmos. Yet in the strange company of black holes and their elusive twins, white holes, time ceases to behave like a simple current. It bends, stretches, and even seems to reverse. To speak of these objects is to speak of time's most delicate dance, a dance where the steps are both hidden and revealed, both possible and impossible. It is here, in the shadow of these cosmic twins, that we begin to feel time not as a clock, but as a living presence. For most of us, time feels like a straight line. Morning leads to evening. Birth leads to age. Stars ignite, burn, and fade. Yet Einstein's vision reshaped this simplicity. In his general theory of relativity, time is not separate from space, but woven with it into a single fabric. Where mass bends that fabric, time bends too. A planet curves space, and clocks tick differently in its presence. A star curves space more strongly, and the river of time slows further. But when a star collapses into a black hole, the bending becomes so severe that time itself stretches into near stillness. To an observer far away, anything falling in seems to slow forever at the horizon, frozen in a dance with time's shadow. This shadowy slowing has long fascinated scientists and dreamers. If you were to fall toward a black hole, time for you would feel normal, your heartbeat steady, your thoughts flowing. But to someone watching from far away, your movements would stretch thinner and thinner, slower and slower, until you seem to hover just above the event horizon, never quite crossing. It is as though black holes teach us that time is not universal. Each perspective tells a different story, and truth becomes a matter of where you stand. White holes carry this strangeness into another realm. Where black holes slow and trap, white holes suggest reversal and release. In the mathematics of relativity, they are not just places of expulsion, but places where time runs outward, forever away from the horizon. If you stood near such an object, you would never see anything fall in. You would only see matter and light burst outward, a constant unspooling of beginnings without endings. Where the black hole embodies the arrow of time marching forward into collapse, the white hull. E embodies the arrow of time rushing outward, away from collapse, refusing to allow entry. Together they feel like partners in a cosmic waltz, one stepping inward, the other outward, both shaping the rhythm of the universe. What makes this dance more mysterious is the role of entropy, the measure of disorder. The second law of thermodynamics tells us that entropy always increases. Cups shatter, stars collapse, galaxies drift apart. Black holes fit this law perfectly. They are the ultimate consumers of order, the great vaults of chaos. But white holes resist. They would decrease entropy, throwing matter outward in a way that seems to undo disorder. To imagine them is to imagine a region of space where the arrow of time points backward, and yet the equations allow it. The mathematics insists that such a partner to the black hole exists, even if the universe itself seems unwilling to host it. Perhaps the greatest metaphor lies in how we experience time ourselves. Just as relativity tells us there is no single universal clock, so too do our lives remind us that time is deeply personal. A joyful moment seems to vanish in an instant, while grief lingers as though eternity itself has slowed. Standing at the threshold of a black hole, time would stretch into infinity. Standing before a white hole, time would become an endless outpouring of beginnings. Both extremes remind us that the ticking of clocks is not the full story. Time is not just measured, it is felt. Imagine drifting at the edge of a black hole, where a single second outside might stretch into centuries for you. Imagine standing at the edge of a white hole, where moments erupt outward endlessly, where time feels like a tide forever receding. Both images bend our sense of reality, and yet in their strangeness they carry something profoundly human, the reminder that time is not a simple ruler against which we measure life, but a dance partner leading us through steps we do not always understand. This dance with the shadow of time humbles us. It tells us that the universe does not obey our intuitions. It whispers that beginnings and endings may not be so rigidly separate, that collapse and release may be partners in a cycle beyond our comprehension. In black holes, time bows inward. In white holes, time bows outward. and between them we find ourselves fragile beings carried by a river we cannot control, yet able to imagine its every twist and turn. To sit with this thought is to sit in wonder. Time, the most ordinary of experiences, becomes extraordinary when we see it through the eyes of the cosmos. It is not a straight path, but a dance floor where gravity and mass and energy lead the steps. Black holes and white holes are not just exotic objects, they are mirrors of time's possibilities, showing us that even the most familiar current may have hidden rhythms, unexpected turns, and shadows we can only glimpse. And in that dance, we learn not just about the universe, but about ourselves. To understand the shadow of time around black holes and white holes, one must surrender the comfort of simple clocks and calendars. These cosmic entities show us that time is not a universal metronome, beating evenly everywhere. Instead, it is woven into space, bending and stretching wherever gravity grows strong. The closer one drifts toward a massive body, the slower the river of time flows. Near Earth, this effect is tiny, measured only by the delicate ticks of satellites orbiting above us. But near a black hole, time slows so profoundly that it becomes almost unrecognizable, an endless pause written into the heart of the cosmos. Consider the paradox that Einstein's mathematics presents. At the surface of a black hole called the event horizon, time for a distant observer stretches to infinity. Nothing seems to cross. A star falling in would appear frozen, its final light smeared endlessly across the horizon, never quite disappearing. Yet for the star itself, time runs normally. It crosses the horizon without hesitation, moving inevitably toward the singularity within. This dual truth reminds us that time is not absolute. It is always a story told from a perspective, and each perspective is valid in its own way. White holes take this paradox and invert it. Where the black hole's horizon refuses escape, the white hole's horizon refuses entry. From the outside, one would see streams of matter and light bursting outward, never ceasing, never diminishing. Yet nothing could ever cross inward. The arrow of time for a white hole points only outward, only away. It is as if the universe is replaying collapse in reverse, a grand unfolding that denies gravity's hunger. The symmetry is breathtaking. Black holes trap the future, white holes guard the past. And yet such a dance strains against the second law of thermodynamics. Disorder grows with time, glasses break but never reassemble, stars collapse but do not reignite, entropy increases and the arrow of time inches forward. White holes seem to contradict this, pouring order into the universe, decreasing entropy, moving against the current of time itself. Perhaps that is why they have never been observed. The universe resists their existence, even as the equations permit them. They are like phantom dancers on the stage of physics, rehearsed in theory but absent in performance. Still, one cannot dismiss the poetry they offer. Black holes and white holes together paint a picture of balance, of inhale and exhale, of collapse and renewal. To think of them is to think of the universe as a rhythm, a heartbeat too vast for us to hear in full. Time is the drum that sets the pace. Black holes beat inward, slowing and consuming. White holes beat outward, releasing and denying. And between those beats lies the music of existence, soft and endless. Scientists have wondered if perhaps the death of a black hole could give rise to the brief life of a white hole. Stephen Hawking's vision of black hole evaporation suggests that these monsters do not last forever. Over unimaginable spans of time, they leak energy, shrinking until they vanish. But some physicists whisper that the end may not be a silence. Perhaps in its final moment, a black hole explodes outward, releasing all it once consumed. To an observer, it would look like the sudden birth of a white hole, a brief fountain of release, a shadow of time running backward before fading into nothing. Others take the idea further, imagining wormholes that link the two. A black hole on one side, a white hole on the other, joined by a tunnel through space-time. To fall into the black hole would not be to vanish but to reappear, expelled through the mouth of a white hole somewhere else, someone else. Such visions are fragile, requiring exotic matter to hold the tunnel open, demanding energies we cannot harness. And yet, in the imagination, they flow with elegance, as if the universe might truly be stitched together by such secret passages. But whether or not these tunnels exist, the concept teaches us something profound about time itself. Time is not one stream. It is many streams, branching and merging, curving and folding. Black holes remind us that time can stretch into near stillness. White holes remind us that time can pour outward endlessly without ever allowing a return. Together, they teach us that time is not a single direction but a vast landscape, and we are but travelers walking its winding paths. Imagine standing at the edge of a black hole, watching stars above you race forward while your own time slows to a crawl. Imagine standing before a white hole, where streams of energy burst outward endlessly, where time seems to sprint away from you, carrying everything outward with no chance of return. Both visions leave us humbled. Both remind us that our human sense of minutes and hours is only a fragile approximation of a far grander reality. And in this grand reality, we find something deeply human reflected back. For our own lives, too, carry moments of stretched time and fleeting time, moments of stillness that feel eternal, and moments of joy that vanish too soon. Black holes mirror the slow grief of lingering sorrow. White holes mirror the flood of sudden beginnings when everything rushes outward at once. Together, they remind us that time is not uniform even in our hearts, that it dances differently for each memory, each experience, each life. So let us drift deeper into the shadow of time. Let us accept that the universe is not a machine ticking evenly, but a living fabric bending, stretching, and sometimes reversing. In the collapse of black holes and the imagined release of white holes, we glimpse a truth both scientific and poetic. That time is not a ruler, but a rhythm, not a line, but a dance. And we, fragile beings on a small world, are invited to join the steps. To finish our journey through the dance of time, let us sit quietly with the mystery that black holes and white holes bring into the cosmos. These two ideas, one proven by observation and the other suspended in imagination, together create a stage where time performs its most delicate steps. Black holes slow and consume, drawing the river of time inward until it nearly freezes. White holes, if they exist, pour outward, denying time the chance to enter. Between them lies not contradiction, but symmetry, a mirror where time itself seems to watch its reflection. The slowing of time near black holes has been measured. Astronauts circling near a massive planet or star would age slightly less than their friends far away, a small but real difference. Near a black hole, that difference becomes enormous. A single hour by the horizon could be years, centuries, or even millennia in the universe beyond. For the traveler, time remains normal. For the watcher, time nearly stops. This duality is not fiction but fact, a reminder that time is not universal. It is woven into gravity, and its pace is never the same everywhere. White holes extend this truth into speculation. If they are real, then their horizons would be the opposite. Places where time is forever pushing outward, where beginnings repeat without endings, where nothing can ever fall inward. To imagine standing there is to imagine being surrounded by perpetual dawn, a flood of light and energy rushing away from a horizon that refuses entry. It would be the mirror of collapse, a fountain of creation without cause, a refusal turned into a rhythm. In this way, black holes and white holes become dancers bound in contrast. One bends time inward, slowing it, stretching it, drawing it into silence. The other bends time outward, accelerating it, flinging it across the void in endless release. Together, they remind us that time is not only about movement forward, but about perspective, about direction, about the possibilities hidden in the fabric of space. They show us that time is more than a line we walk, it is a stage, and gravity is the music to which it moves. The deepest question that remains is whether these dancers ever meet. Some physicists imagine that the interior of a black hole is not a prison forever, but a passage. At its end, they suggest, lies a white hole, releasing what was once consumed. In this vision, collapse leads to release, death to rebirth, endings to beginnings. Perhaps our own universe began in such a way, born as a white hole from the death of something we cannot see. If so, then every black hole we observe might be the seed of another cosmos, every collapse a hidden beginning. Even if such bridges do not exist, the metaphor remains powerful. For time in our own lives, too, often feels like a dance of endings and beginnings, collapses and releases. Moments of sorrow draw us inward, slowing time, making every second heavy. Moments of joy push us outward, making time seem to fly. Black holes and white holes are cosmic reflections of these human truths, teaching us that time is never uniform, never still, always moving in ways we cannot fully predict. And yet, in the face of such vastness, there is comfort. For even though time bends and twists, even though it dances differently in different places, it carries us along in its rhythm. We may not control its steps, but we are always part of the dance. To think of black holes is to remember that some things are beyond our reach. To think of white holes is to remember that some things are beyond our entry. To think of both is to remember that life itself is lived in between, in the space where time flows gently, allowing us to love, to wonder, to dream. So we close this story in peace. Black holes will continue to slow time at their horizons, silent and unseen. White holes may never reveal themselves, existing only in thought and equation. Yet together, they paint a picture of a universe where time is not a single arrow, but a spectrum of possibilities. They remind us that time is flexible, relative, alive. And they invite us to listen, not with clocks or calendars, but with wonder to the soft rhythm of the universe, to the dance of the shadow of time. As you rest in this thought, let the image of that dance linger. Two partners across the cosmos, one pulling inward, one pushing outward, each shaping the rhythm of existence. You are part of that rhythm, carried by the same fabric, moved by the same music. Time is not a straight path, it is a dance, and in its dance you are never alone. Creation is often imagined as a beginning, a sudden unfolding where silence becomes sound and emptiness becomes full. Our universe itself is said to have begun this way, in a great eruption we call the Big Bang, when space and time themselves stretched outward in a single moment of luminous birth. But if we follow the mathematics of relativity, we find another possibility hidden there. The idea that creation itself might not be a solitary act, but a reflection. If black holes consume and collapse, and if white holes release and expel, then perhaps the origin of our universe is not just creation, but a reverse echo, an answering call from the other side of collapse. The thought is unsettling and beautiful at once. The Big Bang has always felt like a unique event, something singular and without precedent, a one-time breath that began everything. Yet when we look closely, its qualities resemble those of a white hole, matter and energy rushing outward, no possibility of looking inward, no entry permitted, only expansion. In this way, the Big Bang itself could be read as the grandest white hole of all, a cosmic refusal turned into a beginning, a reverse echo of collapse in some unseen realm. Physicists who study this idea speak in whispers of bridges between universes. They wonder if what collapses into a black hole in one universe might erupt outward as a white hole in another. In this vision, every black hole is not an end but a door, and every collapse is mirrored by an explosion elsewhere. Oh. Our own creation, then, might be the answer to a death we will never see, the echo of a collapse so distant that its horizon remains forever beyond us. In this rhythm, endings and beginnings are not separate, but linked, as call and response, inhale and exhale, silence and song. This echo is not one we can measure, at least not with the instruments we hold today. What we can measure is the afterglow of the Big Bang, the faint microwave background that still fills the sky. It is the oldest light we can see, stretched thin by billions of years of expansion, a soft whisper of that first great release. Every photon in that glow is like a note from the echo, telling us of a time when the universe was no more than a sea of light and heat. To gaze upon it is to gaze upon the very memory of creation, and perhaps the memory of a white hole's burst. What does it mean to imagine creation as an echo rather than a solitary event? It means that our universe may be part of a greater rhythm, one where collapse and explosion trade places in endless cycles. It means that the cosmos may not be a story with a single beginning, but a song with many verses, each verse born from the silence of the one before. It means that creation itself may be relational, not singular, a dialogue, not a monologue. Even if white holes do not exist as physical objects, the metaphor remains powerful. To think of creation as an echo is to remind ourselves that nothing exists in isolation. Every sound has a reflection, every act leaves an imprint, every beginning is born from something that came before. The Big Bang itself, mysterious and unprovable in its first instant, may carry within it the mark of what preceded it, the silent shape of collapse transformed into a new release. In this vision, the universe is not only born, but reborn endlessly. And yet the echo is not simply repetition. An echo is always changed, softened, stretched. The reverse echo of creation would not be identical to what came before, but transformed. A collapse in one universe might seed a cosmos entirely different from our own, with new laws, new constants, new possibilities. Perhaps there are countless echoes, countless verses, countless beginnings, each universe in its own way, carrying the memory of collapse but rewriting it into new song. As we drift into this thought, we feel the intimacy of it. Creation is no longer distant, abstract, unreachable. It is a conversation. It is a call answered, a silence broken, a collapse reborn as release. We too are part of that rhythm, our atoms forged in stars, our lives carried by time, our questions rising like echoes in the dark. To imagine the universe as an echo is to imagine ourselves as part of something larger than we can see, yet not separate from it. We are the sound of creation reverberating, the reverse echo still unfolding. To walk deeper into the idea of a reverse echo of creation is to step gently into the space between certainty and wonder. The universe as we see it tells us a clear story. Everything once fit within an unimaginably small, hot, and dense point, and then in less than a heartbeat it expanded outward, cooling, spreading, shaping the galaxies and stars we know today. But why it happened, or what came before, remains hidden. Here in that silence, the vision of white holes lingers, offering a poetic symmetry that what we call the Big Bang might be a reflection, a rebirth, an echo of collapse beyond our sight. The mathematics of relativity does not forbid such a vision. When black holes form, they bend space and time into extremes, compressing matter into densities where the known laws of physics cease to function. At that singularity, our equations break down, but instead of ending the story, some solutions extend it further. They suggest that the collapse on one side may not be final, but may lead to an outburst on the other, a white hole flinging outward what was once consumed. If this is true, then every act of destruction is shadowed by an act of creation, and every death is answered by a birth. Scientists who pursue this path often turn to quantum gravity, the yet unfinished theory that seeks to unite the physics of the very small with the physics of the very large. They imagine that at the heart of a black hole, where densities rise beyond comprehension, quantum effects take over. Instead of crushing everything into nothingness, these effects might cause a bounce. In one universe, matter collapses. In another, that collapse rebounds into an explosion, a white hole that we would see as a beginning. Our universe itself could be such a rebound, the grandest echo of all, the reply to a collapse in realms forever hidden. There are models of cosmology that whisper of eternal cycles, universes born, expanding, cooling, then collapsing again, only to rebound and expand once more. Like breath, like tides, like the heartbeat of the cosmos. In such visions, the Big Bang is not unique. It is one beat in an endless rhythm, one verse in a song that never ends. White holes, whether real or imagined, serve as the metaphors of those reversals, the signs that nothing collapses forever without leaving behind the possibility of renewal. And what of us listening here on a small planet beneath a sky full of stars? What does it mean if our existence is part of such an echo? It means that we are children not only of this universe, but of what came before. Our atoms may carry within them the silent memory of a collapse that gave birth to everything we see. Every breath we take, every thought we think is part of a continuation, a verse following another verse, a ripple following another ripple. The Big Bang becomes not a beginning but a bridge, not a singular event but a passage between what was and what is. The evidence we can measure does not yet reveal such bridges. What we see instead is expansion, galaxies drifting away, space itself stretching faster and faster. This acceleration, driven by what we call dark energy, suggests that collapse may not come again soon. But even if our universe does not return inward, even if it expands without end, the echo remains. For the very fact that we exist at all, that creation unfolded into stars and planets and life, carries the pattern of release, the mark of a white hole. What matters is not only whether the echo is literal, but whether we can recognize its rhythm within the silence. To think of creation as an echo also changes how we see time. For in our everyday lives, we think of time as flowing from the past into the future, one direction only. But in the echo, time becomes relational. A collapse in one realm seeds an expansion in another. A silence in one moment becomes a sound in the next. Past and future blur into a circle, each birthing the other. White holes, as the reverse of black holes, carry this cyclical truth within them, the reminder that time itself may be less of a line and more of a loop, a repeating song sung in countless variations. There is something profoundly comforting in this, for if our universe was born of collapse, then death itself may carry the seeds of life. Endings may never be final, but always preludes. The atoms in our bodies, forged in the deaths of stars, already tell us this story. They remind us that collapse gives way to release, that silence gives way to sound. White holes are not only theoretical curiosities, they are cosmic metaphors for renewal, for rebirth, for echoes that carry forward across impossible gulfs. As we rest in this thought, the idea of creation becomes gentler. It is not a violent explosion, but an answering whisper. It is not a singular command, but a dialogue across universes. It is the sound of collapse answered by release, the hush of silence answered by song. And we fragile travelers of time are carried within that song, echoes ourselves, living notes in a chorus far older and larger than we can see. The reverse echo of creation is not only about the cosmos. It is about us too, and the ways we carry beginnings within our endings. To linger with the thought of a reverse echo of creation is to accept that the universe may be far more cyclical, far more relational than our eyes can ever confirm. Black holes teach us of collapse, the silent swallowing of light and matter. White holes, though unseen, teach us of release, of matter and light pouring outward, of beginnings that bloom without endings. Together, they offer a vision where the Big Bang itself becomes not an isolated miracle, but a continuation, an echo following a silence, a dawn following a night we cannot remember. Think again of the afterglow of the Big Bang, the cosmic microwave background that still hums around us. It is a gentle light, stretched thin by billions of years, yet it is the oldest light we can see. In its faint glow, we read the early whispers of creation, the way matter first clumped, the way galaxies first seeded. This afterglow is like the fading note of an echo, telling us of the great release that began our universe. And if we choose to imagine it, it is also the trace of a white hole's outpouring, the memory of a collapse transformed into birth. Such imaginings are not proven by evidence, but they are not forbidden either. In the mathematics of relativity, in the whispers of quantum gravity, in the dreams of cosmology, the possibility lingers. A black hole in one universe may be the womb of another. The death of a star here may echo as the birth of galaxies elsewhere. Our own beginning may have been such an echo, the soft reply to a collapse that occurred in realms we will never touch. In this rhythm, destruction and creation are not opposites but companions, partners in an endless cycle of exchange. What does this mean for us, small beings standing under a sky too vast to measure? It means that we are part of a rhythm much older than our world, much larger than our stars. The atoms that make our bones may have once belonged to another cosmos, carried through the echo of collapse and release. Every breath we take may be part of a song that has been sung countless times before. The reverse echo of creation reminds us that our lives, brief though they may be, are woven into something that does not end but transforms, does not vanish but reverberates. This thought softens the sharpness of endings. Just as stars collapse and seed new stars, just as galaxies drift and reshape, so too do our own endings give rise to beginnings we cannot yet see. Death itself becomes less of a silence and more of a resonance, a note carried forward in another key. White holes, whether they exist in the sky or only in thought, become symbols of this truth. They are reminders that nothing is ever entirely lost, that every collapse carries within it the possibility of release, that every silence carries the seed of a new song. And so the Big Bang, our great beginning, may itself be read as an echo, not an isolated burst but a reply, not a singular command but a continuation of dialogue. To see it this way is to place ourselves in a universe that is alive with memory, alive with cycles, alive with echoes that stretch beyond what we can see. Creation itself becomes gentler, less violent, more relational. It becomes a whisper, a rhythm, a harmony in which we, too, are participants. As we close this story, let the thought settle softly. Perhaps we are not living in the first universe, nor the only one, but in one verse of an eternal song. Perhaps our cosmos was born as the reverse echo of another's collapse. Perhaps our own collapse, far in the future, will be the seed of another's dawn. The universe may not be a single beginning, but an endless unfolding of beginnings, each one answering the silence of the last. Rest in that vision, let it calm you, for it tells us that even in endings there is continuity, even in silence there is sound, even in collapse there is creation. We are part of that continuity, part of that sound, part of that creation. The reverse echo of creation is not far away. It is here within us, within every atom, every breath, every question we ask beneath the stars. Gravity is the quiet hand that holds the universe together. It binds planets to stars, stars to galaxies, galaxies to clusters, and clusters to the great web of the cosmos itself. It is not loud or sudden, but patient, always pulling, always drawing, always reminding matter of its place. Without it, there would be no structure, no stars, no warmth, no worlds to walk upon. And yet, the thought of a white hole invites us to imagine something entirely different. A place where gravity does not hold on, but lets go. A place where the very force that shapes everything suddenly refuses to cling. Black holes are the purest expression of gravity's grip. They are regions where the pull becomes so strong that even light cannot escape. They are gravity's triumph, its final word, its absolute command. But in the equations of relativity, there is also the possibility of their mirror, the white hole. Unlike the black hole, the white hole would be gravity's surrender, a region where nothing can remain bound, where everything is pushed away. It would be as though the universe, for a moment, relaxed its hand and released what it once held. To imagine such a thing is to feel both awe and unease, for gravity is comfort. It is what keeps our feet to the ground, our Earth circling the sun, our galaxy holding its spiral arms. Without it, everything drifts. A white hole, then, is not just a strange object of physics, but a symbol of release, of letting go. It asks us to imagine a universe not of clinging, but of scattering. A universe where gravity's embrace opens and matter is set free. Some scientists wonder if such release is part of the universe's rhythm. For every collapse into a black hole, there may be a corresponding release, a white hole flinging matter outward. Perhaps our own universe began in such a way, gravity letting go of everything it once held in another realm. The Big Bang itself feels like this, not a collapse, but a release, a sudden scattering that allowed galaxies to form and time to flow. In this sense, white holes may not just be mathematical curiosities, but metaphors for beginnings, for the moments when holding transforms into letting go. This image of gravity letting go touches something deeply human as well, for in our lives, too, we often cling. We hold on to memories, to people, to fears, to desires. Gravity becomes a mirror of this clinging, a reminder of how deeply bound we are to what we love and what we fear. But white holes remind us that release is also part of the story. To let go is not always to lose, but to transform. Just as a white hole refuses to hold, so too can we learn that release is not emptiness, but possibility. In the silence of the cosmos, black holes and white holes become opposites not only of physics, but Of meaning, black holes are gravity's deepest embrace, holding everything, never releasing. White holes are gravity's softest gesture, opening the hand, scattering everything outward. Together they form a rhythm that feels almost alive, a heartbeat of the universe, a balance between grasping and giving, between clinging and release. Imagine drifting at the edge of such a place. Instead of being pulled inward, you feel a gentle push outward, as though space itself is exhaling. Matter streams past you, light bursts outward, nothing settles, everything flees. There is no staying, no binding, only release. It is a vision that feels alien, yet strangely peaceful, as though the cosmos itself has learned the art of letting go. And so the white hole remains not only a scientific idea, but a meditation. It invites us to reflect on gravity, not as an eternal grip, but as something that too might one day release. It invites us to see the universe as not only a place of binding, but of scattering, not only of holding, but of letting go. In that thought, the cosmos feels less rigid, more gentle, more alive, a place where even the strongest force has its moments of surrender. To imagine the universe in terms of gravity's grip is to imagine a universe of structure. Stars cluster because gravity pulls them. Planets circle because gravity holds them. Galaxies swirl because gravity threads them together like beads on an invisible string. But to imagine the universe when gravity lets go is to imagine something altogether different. A universe without binding, a universe of scattering, a universe where release is stronger than pull. This is the essence of the white hole, the strange twin of the black hole, a cosmic place where nothing is held, everything is freed, and gravity's embrace is transformed into a gesture of surrender. In the world of black holes, the story of gravity is one of triumph. Stars collapse and gravity wins, pulling even light itself into silence. Nothing escapes, everything falls inward. Yet in the idea of white holes, the story is reversed. Gravity does not win. Instead, it refuses to cling at all. Nothing can fall inward. No star, no light, no dust, no whisper of energy may cross its horizon. Instead, everything is expelled outward, released before it can ever be bound. This reversal unsettles us because it contradicts the direction of time and entropy. But in its strangeness, it offers a vision of balance, as if the cosmos requires not only clinging but letting go. Letting go is not something we easily imagine in physics. Our equations are built upon laws of attraction, of cause and effect, of forces pulling matter into relationship. But white holes are the mathematics of refusal, the geometry of release. They tell us that for every equation of collapse, there is an equation of expansion. For every star that dies into silence, there may be a counterpart that breathes outward, scattering beginnings where endings once seemed final. The symmetry is haunting, delicate, and strangely reassuring. It suggests that the universe, in its deepest structure, always carries the possibility of renewal. Some physicists propose that white holes are not objects that exist forever, but moments, brief flashes of release in the fabric of time. Perhaps when a black hole has consumed all it can and begins to wither away, it does not simply vanish. Perhaps it bursts outward in one last release, scattering the matter it once devoured. Such a moment would be like gravity unclenching its hand after holding for eons, a final exhalation after an endless inhale. In that vision, the universe becomes a rhythm, with collapse and release trading places in an eternal cycle. This rhythm touches not only science, but our imagination of life. For how often do we, too, live in the tension between holding and letting go? We cling to what we know, afraid of loss, comforted by gravity's embrace. Yet sometimes we are asked to release, to let go, to scatter what we have held so tightly. And in those moments, like in the vision of a white hole, we discover that release is not destruction, it is transformation. It is the scattering of seeds into new soil, the opening of a hand so that something new may take flight. Imagine for a moment that our universe itself was born from such a release, that before the Big Bang there was collapse, and that collapse reached a point where gravity could no longer hold. In that instant, gravity let go, and everything we now know, galaxies, stars, planets, life, rushed outward in a flood of beginnings. To think of our cosmos this way is to think of creation not as a violent explosion, but as a gesture of release, a cosmic opening that allowed possibility to flow. It is gentler, softer, more like a breath than a bang, more like a letting go than a breaking apart. The physics of white holes may be fragile, but their metaphor is strong. They remind us that not all strength is in holding, there is als. O strength in releasing. Black holes show us the might of gravity's grip, a force that holds even light. White holes, though unseen, show us the might of gravity's surrender, a force that holds nothing, that refuses to bind, that allows everything to escape. The balance between the two becomes a story of the universe itself, the story of inhale and exhale, of embrace and release, of silence and song. Even in human science, we see this pattern reflected. Stars collapse to form black holes, but they also explode as supernovae, scattering heavy elements into space. Those scattered atoms become the seeds of new stars, new planets, and eventually new lives. Collapse and scattering are woven together, inseparable parts of the same story. White holes become a symbol of that scattering, the great reminder that holding is never the whole truth. The universe also knows how to let go. And so, to imagine when gravity lets go is not only to imagine a white hole in the sky. It is to imagine a universe that carries both strength and softness, both embrace and release. It is to imagine a cosmos where even the mightiest force knows when to open its hand. And in that thought, we are reminded that our own lives, too, are shaped by both clinging and letting go. We are bound by love, by memory, by time. But we are also freed by release, by surrender, by the gentle scattering that makes space for what comes next. Just as the universe breathes, so too do we. As we arrive at the final steps of this journey, let us rest in the image of gravity not as a grip that never loosens, but as a hand that sometimes opens. Black holes remind us of gravity's strength, its ability to hold so tightly that nothing, not even light, can slip free. White holes, whether real or imagined, remind us of the opposite, a cosmic gesture of release, a place where nothing is held, where everything is set free. To linger in this contrast is to see the universe itself as a balance between holding and letting go. The thought of gravity letting go changes how we think about beginnings, for beginnings are always tied to release. A seed must leave the stem to become a tree. A breath must be exhaled before another can be drawn. Stars must release their elements in death before new stars and planets can be born. The Big Bang itself was the greatest release of all, a moment when gravity, rather than holding, scattered. Our entire existence rests upon that letting go. Without it, there would be no galaxies, no suns, no Earth, no us. Creation, it seems, is less about holding tight and more about opening wide. There is humility in this thought. For much of our lives, we believe strength lies in clinging to security, to power, to certainty. But the universe suggests another kind of strength, one found in surrender. White holes, even as fragile mathematics, remind us that letting go is not weakness. It is a different form of power, a power that allows transformation, that gives space for something new. In physics, as in life, holding is only one half of the story. The other half is release. Imagine standing at the horizon of a white hole, where light and matter stream outward endlessly, never to return. To the eye it would be dazzling, overwhelming, a constant scattering, a perpetual exhale. Yet at the same time it would feel strangely peaceful. There would be no pull, no weight, no binding. Everything would move outward together as though the cosmos were breathing in harmony. That breath, that exhalation would not be chaos but rhythm. It would be release turned into song. Some physicists suggest that in the far future, when black holes themselves reach the end of their lifespans, they may transform into bursts of release. After eons of consuming, they may finally scatter, letting go of all they once held. In this vision, even the most unyielding structures in the universe are temporary. Even the strongest grip must one day open, and when it does, it leaves behind not emptiness but possibility. Outward flows energy, light, and memory, carried forward to seed something new. This is the final lesson of white holes, that nothing holds forever. Not stars, not galaxies, not even gravity itself. The universe is made of cycles of binding and scattering, collapse and release, silence and renewal. Our lives mirror this rhythm. We hold for a time, then we let go. We cling to moments, then we release them into memory. We hold one another, then we let one another go, carried by time. And though the letting go is difficult, it is also part of the dance, also part of the song, for only in release can there be renewal. As we close this final story, let the image of gravity's release linger in your thoughts. Let it soothe you, for it tells us that even the mightiest forces are not unyielding. It tells us that letting go is natural, woven into the fabric of existence itself. It tells us that endings are not failures but openings. That release is not silence but possibly. Litty, that when gravity lets go, creation begins again. And so rest in the rhythm of the cosmos, in the inhale of black holes and the exhale of white holes, in the binding of stars and the scattering of galaxies, in the holding of memory and the releasing of time. Rest in the knowledge that you too are part of this rhythm, that in your own holding and letting go you echo the universe itself, that when gravity lets go it is not an end but a beginning. It is the softest truth, the gentlest promise, the eternal breath of creation.